So here is a chart for reinforcing bar dia and area. We can use these bars in column design, like, or any type of structural design. Number 3 bar, number 4 bar, number 5 bar, number 6 bar, number 7, 8, 9, 10, 11, up to number 11 bars. So these are indicating the number of the bar. The diameter of a particular number bar is the number of the bar divided by 8. So if we know the diameter of a bar, we can easily calculate the area of the bar. We know that a bar is generally circular in shape, so the area of a circle is pi d square by 4. So if we know the diameter d, then we can easily calculate the area, which is pi d square by 4. So for number 3 bar, the area will be 0.11 square inch. Number 4, it will be 0.20 square inch. Actually the bar dia was in inch that we have calculated from number of bar, and so the area we have calculated here in the chart we have provided for inch. So from our previous slides, we have already seen that for a column, the minimum reinforcing bars for a column, the minimum longitudinal bar should be number 5. So we can use number 5 as longitudinal bar, and any other bar higher than that. And for stirrups or lateral reinforcement, we generally use number 3 bar, and sometimes number 4 bars also, but in most of the cases we'll be using number 3 bar as lateral reinforcement. Now let's see our first example. So in this first example, we have been asked to design a square tight column which will be supporting an axial dead load of 130 kip, and the live load will be 180 kip. The value of steel percentage, or the ratio of reinforcement, is given as 2%, and the compressive strength of concrete is given as 4000 psi. We know that 4000 psi means 4 ksi, and the value of yield strength of steel is given as 60,000 psi. That means here we have asked to use number 60 grade bar. 60,000 psi means 60 ksi. We know in order to convert from psi to ksi, we need to divide it with 1000. So here we have asked to design a column which should be able to carry a dead load of 130 kip and live load of 180 kip. That means in total we need to design a column which can carry a total load of 130 plus 180, which means 310. But in general sense, or in order to design a column, can we consider the load that's given? No, exactly not. We need to consider some factor of safety also. For that case, we need to factorize this load which is given here. In USD method, that means ultimate strength design, that we have discussed in our previous class. In USD method, we need to factorize the load. Here we are using the USD method. So in order to adopt some factor of safety, we are factorizing the dead load with 1.2 and live load with 1.6, and this factorizing equation is has been taken from the BNBC guideline. So 1.2 into 130 plus 1.6 into 180 is equals to 444 kip. That means we need to design a column which can carry a ultimate load or a design load of 444 kip. So we already know the design strength equation of our column. Phi Pn is equals to phi into alpha 0.85 fc prime ag minus as plus fy as. So as we have asked to design a square tight column. For a square tight column, we know that the value of phi is equals to 0.65 and alpha is equals to 0.8. So we have to plug this value here. Phi is equals to 0.65, alpha is equals to 0.8, and the design strength value, that means the load that we need to design for, we will have to plug it here, 444 kip. And the value of Fc prime is given 4000 psi. As we are plugging the value of ultimate load as kip or kilopound, so we need to plug the value of Fc prime as ksi. So we need to convert it to ksi, which is 4 ksi. 4 we have plug it here, and the value of Fy we have plug it as 60, converting it into ksi. Moreover, it's given that the steel ratio is 2%. That means the value of rho g is equals to 2%. 2% means 0.02. So we know that the equation of steel ratio is equals to, steel ratio means area of steel divided by the area of concrete, or the gross area. So it means that 0.02 will be equal to AS by AG, which is AS means area of steel, total steel area that we are using, total summation of the area of the steels that we are using in designing this column, and AG will be the gross cross-sectional area of the column. So we can say in other way that AS is equals to, if AG moves to this side, AS will be equal to 0.02 into AG. So in place of AS, we are replacing with 0.02 into AG, 0.02 into AG, 0.02 into AG. So we can see from this equation that only the value of AG is unknown. So from here we can calculate the value of AG. So that means we have already calculated the gross cross-sectional area, which is 188.40. So the column that is required to carry this load of 444 kip should contain an area of, or should include an area of 188.4 inch square at least. So in order to get the dimensions, as we are asked to determine the square tight column, we just need to square root this answer, and this way we can calculate the dimension. We are taking the square root of 188.4 and considering the higher rounding, we can see that the area or the dimension of the column will be 14 inch into 14 inch. So in this way we are calculating the dimension of a square tight column which can carry a load of 444 kip. So now we have already calculated that the area of the, or the dimensions of the column should be 14 inch into 14 inch. So now we need to calculate the area of the reinforcement. We know that 0.02 is equals to AS by AG. We have already calculated the value of AG, so from here we can calculate the value of AS. This is a procedure, but we can do it in another way, which is just plugging the value of AS here, plugging the value of AS here. We have already calculated the value of AG. So as we have taken 14 into 14 inch, that means the total area would be 196 inch. We have taken 14 into 14 inch considering the higher rounding option, as we can not take the dimension of the column as decimal, so we have take the higher rounded value. Now in order to calculate the value of AS, we are plugging the value of AG here, so other value are known, so we can from here we can calculate the value of AS, which will be 3.31 inches square. So in design guideline we have already seen that um, the minimum 4 longitudinal bars should be used for tight column and no odd number of bars. That means we can use 4 or 6 or 8 bars in total. So the total area is 3.31, and we can, from the design guideline we have also seen that the minimum number of bars should be number 5. We cannot consider less than that. Minimum number 5 bar can be used, and the area of number 5 is 0.31. If we use number 31, then the number should be higher, but if we can use number 7 bar, then we can see here that 0.6, its area is 0.6. so the total area of the steel is 3.31. so how many number of 7 bar we need to use? That means 3.31 divided by 0.6. so we have got 6 number of bars, number 7 bars we have to use in order to design this column. Here also we have considered the higher round, we have also considered the higher rounded value. It may come something like 5 point something, but considering the higher rounded value, the value will be 6. so 6 number 7 bars should be used in this column. So we are using 6, 1, 2, 3, 4, 5, 6 number 7 bars. We'll have to conclude in this way. So moreover, we need to use lateral reinforcement or tie bars. So in order to design the tie bar, we need to remember 3 things, which are the minimum diameter of the tie bar or minimum spacing. The minimum, we know that for designing tie bar we generally use number 3 bar. So the area of number 3 bar is 0.11 inches square. So while designing the tie bar, we need to consider these 3 and take the minimum one. So the spacing of the tie bar should be the minimum of these 3, starting with 48 dB. Here the dB means, or the dB indicates the diameter of lateral reinforcement. Here, as we are using number 3 bar as lateral reinforcement, so the diameter of 3 bar will be 3 by 8. 3 by 8 into 48 is equals to 18 inch. 16 dB. Here the dB indicates the diameter of longitudinal bar. We know that we are using number 7 bar, so the diameter of longitudinal bar will be 7 by 8. So 16 dB means 16 into 7 by 8. And number 3rd, which is least column dimension, we have got our dimension as 14 inch into 14 inch. So the least dimension is 14 inch. So from these 3, which is 18 inch, 14 inch and 14 inch, the least value is 14 inch. So the minimum reinforcement spacing, or the minimum lateral reinforcement spacing, or the tie spacing should be 14 into 14 inch. 14 inch. So we have concluded in this way. Use number 7. Actually it's wrong, it will be written as number 3, as we have considered number 3. Use number 3 at 14 inch into 14 inch center to center. That means the center to center spacing of the ties will be 14 inch. To make it more clear, we can see here these are the lateral reinforcements or tie bars. So for this example, the spacing of this lateral reinforcement or tie bars should be 14 inch. We have got this from 3, considering minimum value of this 3. So in this way we need to sketch the figure. We know that we need to use 1.5 inch clear cover. So into the total in the main dimension will be 14 inch, so subtracting 1.5 inch from two sides, we know that we need to use 1.5 inch minimum clear cover, but for coastal area we have to consider 2.5 inch. So we are considering here 2.5 inch, 2.5 inch, 2 point, plugging the value of 2.5 inch and subtracting it from both sides. So 14 minus 2.5 into 2 into 2, which is 9 inch. So the columns the columns longitudinal bars should be in this 9 inch 9 inch dimension. We have included the bars in this 9 inch dimension, and the reinforcement, lateral reinforcement on the tie bar should be number 3 bar at the rate of 14 inch. So in this way we need to conclude by sketching this figure. In this second example, we are asked to calculate, or we are asked to design a spiral column. Spiral column means circular column which can support a dead load of 130 kip and a live load of 180 kip. And similarly, like the previous one, the longitudinal reinforcement ratio, which is given as 2%, the value of rho g will be 2%, fc prime will be 4000, which means 4 ksi, and fy will be 60 ksi. So we have to design exactly this for the same question, but this time we need to design it for spiral column. So in order to complete our task, the first thing we need to do is we need to factorize the load, as we are using USD method. So by factorizing the load, we are getting the total load or the design load. So plugging the design strength equation, like the previous example, we are calculating the value of AG, but this time we are calculating the value of AG, but this time, as this is a circular column, the value of phi and alpha will be different. We know that for circular column or for spiral column, the value of alpha is 0.85 and the value of phi is 0.75. so we need to plug here 0.75 and 0.85, and others value will remain unchanged. In this way we will get the value of AG as 153.67. so now, as we are asked to calculate, or we are asked to design the circular column, so the equation for total area, or the formula for total area or gross area should be pi d square by 4, as this is the formula for circular or a circle. So from pi d square by 4 should be equal to 153.67. so from here we can see that the value of d is unknown, or diameter is unknown. From this we can get the value of d. The value of diameter should be 14 inch. From our answer we will get it as 14 inch. Here also we have considered the higher rounded value. So if we consider the higher rounded value 14 inch, the gross cross sectional will be pi d square by 4 will be AG is equals to 153.93. so plugging the value of AG, we will be able to calculate the value of AS, total area of the steel. And now from this total area of the steel we can calculate the total number of bars. So like the previous one, we have calculated the total numbers of bars should be number 7 bar, and total number of bars should be 6. So 6 number 7 bars. But here is the difference for lateral in this case we are using spiral reinforcements to hold the longitudinal reinforcements in place. In order to hold the longitudinal bars in place, we need to use spirals or spiral reinforcement. So these are the spirals. from it is surrounding the longitudinal bars and holding it in place. So it's there is a difference in between the designing of tie bars and spiral bars. In this case, we need to calculate the diameter of the concrete core first. As we know that the diameter we have got from our answer is 14 inch. This is the gross diameter. This is the gross diameter. That means we need to construct a 14 inch. We need to construct a 14 inch column. We need to construct a 14 inch column. 14 inch column. So 14 inch, as we need to allow a some portion for clear cover, so we are subtracting 1.5 and 1.5 from two sides. That means 3 from total. That means 14 minus 3 will be 11 inch. So the diameter of the core will be 11 inch, in which the spirals should be placed, and the outside ones are clear cover. So inside this 11 inch, the longitudinal bars will be placed. So the diameter of the core is 11 inch. So from here we can write that diameter of core is 11 inch. So the diameter, so the area of the core will be pi dc square by 4. So we are getting the area of the core. Now we need to calculate the reinforcement ratio for the spiral. So the reinforcement ratio for longitudinal bar are given as 2%, but now here we have to calculate the reinforcement ratio for spiral. So in order to calculate that, we need to remember this formula, which is 0.45 Ag by Ac minus 1 Fc prime divided by Fy. Fy and Fc prime is given in the question. Ag is the total gross area, or the total area or gross area, which we have calculated as 153.93. Ac, diameter of the area of the core, we have calculated few seconds before, and 0.45. From here we will get the ratio of the lateral reinforcement. So from this rho s, we will need to calculate the, using this rho s, we will need to calculate the spacing of the spiral bars. Okay, so spacing of the spiral bars means the vertical distance in between two spiral. So we need to calculate this spacing. So in order to calculate this spacing, we have already calculated the ratio of spiral. Then we need to calculate the spacing of spirals. So we already know that for spirals or lateral bars or tie bars, most of the time we use number 3 bars. Then the area of number 3 bar is 0.11 inches square, and the area diameter of number 3 bar is 3 by 8 inch. So using these values, we need to remember the spacing of the spirals equation, which is this one. So for as dc minus db, the dc is the diameter of the core, which is 11 inch. db is diameter of the spiral bar. We know that the diameter of the spiral bar is 3 by 8. We are plugging 3 by 8 in place of d by db. And as means area of the spiral bar, which is 0.11 inches square. The value of rho s we have already calculated. Ratio of reinforcement, spiral reinforcement, which is 0.0186. We have plugged it here. And at last dc square, dc means diameter of core, 11. So in this way we will be able to calculate the spacing also, and we will have to conclude drawing this figure. So we can see here 14 inch diameter concrete column. So in both sides we are providing 1.5 inch clear cover, so that diameter of the core will be 11 inch. We'll need to place 6 number 7 bars. So we need to write it here, 6 number 7 bars, and the spirals should be number 3 bar, but the spacing should be 2 inch center to center. Okay, so in this way we need to calculate the reinforcement and the cross-sectional area and conclude the design. Thank you.